Welcome to Ms. Quinn's geometry class. Today we are working on 2.2 and 2.3, conditional statements and converses. A conditional statement is an if-then statement. It looks like if something then something else, or P implies Q is an if P is true, then Q is true kind of statement. For example, if you live in Palmer, then you live in Alaska. The you live in Palmer part is the antecedent. The you live in Alaska, the part that follows then, is the consequent. And this appears to be true. If you live in Palmer, Alaska, I suppose there might be other Palmers, then you would live in Alaska. A counterexample to a conditional is a specific case where the antecedent, the part after if, is true, and the consequent, the part after then, is false. You only need one counterexample to disprove a conditional. An instance of a conditional is a specific case where both the antecedent and the consequent are true. All right, let's check out this conditional. If you attend Mrs. Quinn's math class, then you attend Palmer High School. Since I don't teach anywhere else for any other institutions, if you're in my class, you are definitely attending Palmer High. An instance of that conditional would be any student in this class. You are an instance of this conditional. There are no counterexamples, so it is true. Let's just review identifying the antecedent and the consequent. The antecedent comes after if, and the consequent comes after then. All right, let's talk about the converse. The converse of a conditional just switches the order. The converse of P implies Q is Q implies P. As an if-then statement, this would say if P is true, then Q is true. And the converse just takes it in the opposite direction. If Q is true, then P must also be true. Let's look at a conditional. If you are a dog, then you have 4 legs. The antecedent is you are a dog. The consequent is you have 4 legs. The converse would be if you have 4 legs, then you are a dog. The antecedent and the consequent have merely switched places. So the converse merely switches it. Now let's think if we can find a counterexample for either one of these. I can think of a dog, sadly, that doesn't have 4 legs. So I'm going to have to say that this one's false. Most dogs have 4 legs, and hopefully they're able to keep them. I can definitely think of a counterexample for this one. If you have 4 legs, you're not necessarily a dog. You could be a lion. You could be many other things. All right, now let's look at inequalities in our converses. If I say Q implies P, that would mean that if this is true, then this must be true. If a number is less than 5, is it less than or equal to 12? Absolutely. 5 is less than 12, 4 is less than 12, 3 is less than 12. So this statement is true. Now let's look at its converse. Its converse would be P implies Q. If P is true, if X is less than or equal to 12, then it must be also less than 5. I can think of a counterexample. How about 8? 8 is not less than 5, so the converse would be false. All right, let's practice a little bit more with converses, and then I'm going to have you try a few. If you are 16 years old, then you are older than 12 years old. My converse would be if you are older than 12 years, then you are 16. And that's not necessarily true. I could be older than 12 years, but not 16. How about if I was 13? Number 2, if you eat your vegetables, then you will grow tall. converse would be if you grow tall, then you ate your vegetables. Also not necessarily true. If you legally drive a car in Alaska, then you are 14 or older. The converse would say if you are 14 years or older, then you legally drive a car in Alaska. Last but not least, number 4, if you are alive if you are born. Here we flip-flopped it, and notice that the if statement came last, just to trick you. So if you were born, you are alive. Our converse would say, if you are alive, then you are born. And that's true. What I would like you to do for tomorrow are these 2 questions. Bring them in on a separate sheet of paper, and I will see you tomorrow.